Hey you guys, this is Mr. Sal. This is 2.3 systems of 3 variables. We're going to be solving these with elimination. So thanks for watching. Don't forget to like and subscribe, and let me know what you think about the video below in the comments. Thanks again. This chart doesn't, or diagram, whatever you want to call it, may not mean a lot to you guys, and it may not show very well on the screen here, but let's look at these one at a time actually. So if we have 3 variables in an equation, it no longer creates a line. It creates a plane, which is just kind of like a flat surface, right? If those 3 planes collide together, you have 2 options. They can either all 3 collide at one point, as you see here, okay, or it is possible for them to come together. Collide sounds better, right? Like in a movie, you wouldn't say they intersect. You'd say these 3 collide. Anyways, these 3 are coming together in such a way that they form a line, which means that would have now infinite solutions, because on a line we can show many different solutions, well, infinite solutions. So if that happens, as you see there, we'll have infinite solutions. On the other hand, if the 3 planes never touch each other, then they're just parallel, all 3 together. But as we see here to the right, though, if they only collide 2 at a time, I mean, it's good the 2 planes are intersecting along that line, but the third one will never intersect at that point or line, okay? Because it's parallel, the plane is parallel with that line, and same with this line. Now this pink one is parallel with that line, and this line is now parallel to the green plane. Now in 3 dimensions, it's hard for us to usually think of parallelness in 3 dimensions, but it is possible, as we see here, okay? Both of these would provide us with no solutions, okay? So just be aware. I mean, you won't see it like this. We're not going to ask you to graph this stuff, as fun as it is, but it hopefully will help us to understand the different types of solutions that we'll get by solving these. That middle one right there shows that all 3 planes are the same, which still has infinite solutions. It's just not a line anymore. They're actually it's just a plane, which is okay. Now this is the process. We're solving a system with 3 variables. We do have to choose, at least with elimination, okay? This is 2.3, and 2.4 we're going to use a different method, which you may or may not like, but you'll need to know how to do both of these. Choose a variable to eliminate. Yes, just like with regular elimination, choose the variable you want to eliminate, okay? Now since we'll have 3 variables, we're going to have 3 equations, which means, yeah, we may use one of the equations twice. You don't necessarily have to choose it at this point. But you do have to choose 2 equations and then eliminate the variable that you chose to eliminate in that first step. Okay, now you've got to choose that last equation that hasn't been used. You've got to choose it with one of the other 2 equations to eliminate the same variable. What that does is it's going to create a system with 2 variables because you eliminated the other one twice. So now you have a system in 2 equations, which we know how to solve, and we loved it. And you get to choose if you want to use elimination or substitution at that point. Okay. For the most part, we'll be using elimination. So you'll eliminate one of the other variables. You'll solve for the one that's left over. And then you plug it back in, and then, well, you'll see some other systems. But we'll plug it back into the 2 equations with the 2 variables, not with the 3, to solve for the next value, which gives us 2 values. And then we'll plug it into one of the 3, which will give us the 3rd value. That doesn't have to make a lot of sense now, okay? But I hope that it will eventually. Okay. the final step there is to check your work, which we should always do, especially on exams. There's a button. So we'll solve this system, and we'll give our answer as an order triple, right? Because we're looking at 3 variables here. So that means that in the order triple, we'll have 3 values, 2 commas. So the first thing we should do is choose a variable to eliminate. Just looking at this system, I would choose to eliminate the y's because I have 2 of them which are opposites to one of the other coefficients, which doesn't have to make a lot of sense yet either, too. But I'm going to eliminate them nonetheless. So I'm going to choose the top equation and then the middle equation, and then combine those to eliminate the y. Alright, so I'll write that down so we don't forget that we are eliminating the y's first. Eliminate y. It doesn't have to sound like a hit list or anything, but in any case, we're going to eliminate the y's. So I'm going to use those first 2 equations. Let's write those out. So there's those 2 equations, and this is extremely convenient because the coefficients of the y's are already opposites. So when I combine these 2, the y's are going to eliminate. But I need to combine each of the separate terms. 6x plus 12x is 18x. 4z minus 5z is a negative 1z. You don't have to put the 1 there. And then 14 plus 43, 57. Now we can feel good about that because we did eliminate the y's just as we had planned. And but we got to do it again, right? But we've got to do it, the third equation we haven't used. So we know we have to use it again to eliminate the y again. Otherwise we'll just keep going in cycles in the same cycle. Okay. So I'm going to write it out. Alright, so I have that third equation. I just need to choose which other one I want to combine it with to eliminate the y's. And we can see if I combine it with the top one, just like with the second one, with the top one, it eliminated the y's right away. Okay, so I'm going to combine it with the 6x minus 2y plus 4z equals 14. Alright, so combining these, more choices here. So we're going to combine these. 6x minus 24x is a negative 18x. And our y's cancel out again, which is what we wanted. 4z plus 1z is 5z. And then 14 plus negative 83. Alright, so we have these 2 equations now. I don't know how they did this, but they set these up very nicely for us. See, now I have 2 equations. Well, let me write these again, alright? So it looks like a new system, but now with 2 variables, not 3, okay? Okay, now that we can see those, it's a new system, which we get to choose what we want to eliminate. And again, this is where it's very nice. If I choose to eliminate the x's here, I will be left with just the z's. So if I add those 2 together, they cancel out. So 0. Negative 1z plus 5z is 4z. And 57 plus 69, I got negative 12. Now yeah, that's always nice for our first problem where things just work out beautifully like this. But if it were to take some manipulation like we did before, where we're multiplying it so that we get the coefficients opposites so that they will eliminate, then so be it, you know. We may have to do that sometimes. So yeah, we just divided both by 4. And now, excuse me, z is negative 3. Now I got that red equation and then the purple one with the 2 variables. And I need to go back into one of those 2. And I'm going to replace z so that I can solve for x. I'm looking at the red one because it's just a negative 1 coefficient of z. Some of you may choose the purple one, which would be fine as well. Okay, but I'm going to choose the red one. I'm going to replace z and then solve for x. Alright, so there's that. I can make that a plus 3 right there. So I'll subtract 3 from both sides. And finally, divide both sides by 18. I apologize. I should have been putting those in the order triple, right? So x is 3 and z is negative 3, which means that we should be ready to go back into one of the other three equations, the original three equations, and replace x and z into one of them and then solve for y. So just replacing the x with 3 and then the z with negative 3. And then we got minus 2y, that's minus 12, that's equal 14. I can combine those two, 18 and negative 12, that gives us 6. Now we'll subtract 6 from both sides, and then divide both sides by negative 2. So y is negative 4, and there's our order triple. Now we should check this, okay, now remember with the instructions, we should check with all three equations, just by replacing those values in. So let's go ahead and do that. 6 times 3 minus 2 times negative 4 plus 4 times negative 3 times negative 3. And that is 14, so that one's good, but we should do it the other two, right? So we got these three equations, once again, and we'll write our answers in order triple, that's okay. But, what the heck, let's put that triple up now. And we'll fill in the blanks later. But, let's choose which variable we want to eliminate first, and it doesn't matter which one we choose. Alright, so we got the middle and the bottom one. So let's multiply this top one by negative 1. Okay, that's going to change it into a 5x plus 6y, and we can see now that z has an opposite coefficient and the 35 is positive. So I'm going to work with this straight from this point. Okay, so I'm going to add each of these together, which will eliminate the z's. 6x plus the 5x, 11x. Negative 4y plus 6y is a positive 2y. The z's eliminated, and then negative 14 plus 35.
It's a negative 35.
Dang it. Sorry, this may help if we put a line there now, just to separate it in our minds, right? Well, that's one equation in the new system, but we need the other one, right? So since we use the bottom two, we will need to use the top one. Negative 4x minus 2y plus 1z equals negative 14. And then we get to choose which of the two equations we want to use. So even though these both equal negative 14, they won't eventually, okay? So let's multiply that top equation, because we already chose to eliminate the z's. I'm just going to multiply that top equation by negative 5, which will make the coefficient of the z now negative 5. So the z's will cancel out. Alright, but we got to multiply the rest of it, right? So yeah, now that I've got that, and yeah, again, it may help us to see that separated. So I'm looking at just those two equations, the black one and the purple one. So now when I combine these, well, add them together. So I've got my 6x plus the 20x, which is 26x. Negative 4y plus 10y is a positive 6y. And yeah, now our z's canceled out, which is what we wanted, right? Because now we got a system with two variables, but no z's. And negative 14 plus the 70 is 56. All right, so the next step is, I'm going to write this now as a system, so it's visually a little bit more like we're used to seeing, okay? So I'm just going to stack these two together. So we have these two equations now, and we're just going to solve it like we would any regular two-variable system, which means we have to choose now which one to eliminate. I'm going to choose to eliminate the y's, because 6 and 2 are easy to work with, and 11 and 26. So what I'm going to do is I'm going to multiply the red equation by negative 3, which will give us opposite coefficients for y. And I'm not doing anything to that purple equation. It's just going to stay the same. Alright then, now when I combine these two, or add them together, the y's cancel out just as we had planned. Negative 33x plus 26x, I got negative 7x. And negative 63 plus 56, also negative 7. So we'll just divide both of these by negative 7, and x is 1. And I'll write that in my order triple so that we have it down. Now here's the thing with solving for y is we have the red and then the purple equations. Which one do we want to use to solve for y? Because it's not going to matter which one we use. Alright, so let's use that red one. But I'm going to go back in and replace the x with the value that we have for x, which is 1. Now 11 times 1 is pretty nice. Just 11. And to solve this one, we'll subtract 11 from both sides. And then finally, we'll divide both sides by 2. And we get y is 5. Which I'll put in my order triple. So now to solve for z, and again, since we eliminated it first, we're solving for it last. We just need to choose one of the three equations that we started with to solve for z. So again, and now that we have that, let's go and replace our x and y values with the values we have. Well, let's go ahead and multiply these out. 6 times 1 is 6. 4 times 5 is 20. 6 minus 20 plus 5z equals, that should have been negative 14, right? Alright, then we'll just combine the green. 6 minus 20 is negative 14. And we want the z's by themselves, so we'll add 14 to both sides. Alright, now at this point, I get a few different reactions on exams, alright, based on the work that I've seen. Some people look at this and say, 5z equals 0, no solution. Why? Because 5 does not equal 0. But it's not asking if 5 equals 0. It's asking you what multiplied by 5 is 0, which hopefully is easy. 0, right? Anything multiplied by 0 is 0. So, well, formally we would divide both sides by 5. And we get z. Well, 0 divided by 5 is 0. 0. That's nice. But don't forget, okay, you should check your answers. Just for the sake of time, we're not going to here. But remember, if you go in and check and find that you found anything that's false or made the equations false, you have to go back and just check your work. For the most part, I find that people that show this much work usually just miss like a minus or a plus somewhere. Okay? Or like I did right there. I almost wrote positive 14 where I should have wrote negative 14. I fixed it. But it's usually something small like that that changes the answer very badly, and usually end up having some really horrible looking decimals as well. So we will eliminate the z's by the student choice. Alright, if we're eliminating z, what two equations do you guys want to start with? Alright, wise choice on this one, because we don't have to multiply either of these equations by anything to eliminate the z's. They are already opposite coefficients, so they will eliminate right away. And we got 6x plus negative 1x is 5x. Negative 2y plus positive 3y is positive 1y. And then we got negative 15 plus 30, 15. So again, that gives us our first equation in our system, but we need a second equation. Okay. What do we got to do to eliminate the z's? Alright, multiply that top one by 2. I'll separate these so we don't get them mixed up again. 2 times negative 3, negative 6x. 2 times 1 is a positive 2y. You guys see a pattern already. 2 times negative 2z is a negative 4z. And we chose to eliminate the z's, and sure enough, they will cancel out. And then we got 2 times 8, which is 16. This is going to be pretty close, but let's go ahead and add each of these just because we think it's so fun. So the x is canceled, the y is canceled, and the z is canceled, even though all we wanted was the z's to cancel. That is okay. It just means we got 0 equals negative 15 plus 16 is 1. So, does 0 equal 1?
No.
Ever? Nope, it does not. So, since these two will never, that means they will never collide, right? So they're parallel to each other. That means that this already has no solutions. If the two don't ever intersect, then the third one, even if it does intersect, doesn't matter, because there's never a solution for any of them, for all three.
It was okay for us to have.
Let's address that case. So let's look at this a little different. So let's say that it was 0z, just because we want it to be, equals 1. Now what would we do to solve this? We would divide it by the coefficient of z, just purely by algorithm, right? That's what we're used to doing. That's what we do. 0 divided by 0, it doesn't equal 1, but whatever. What's 1 divided by 0?
0.
Error. That's a domain error. It's undefined. It's infinity, right? Which actually is still increasing, even as far as we know. And so that is why this has no solutions. So which two equations you guys want? We've chosen to eliminate y, but what two equations you guys want to use to start out with? So yeah, I'm assuming you guys chose that because the top equation has opposites with the second and third equation. So I'm going to stay away from those bottom two. But you could. Okay? It really is just a matter of changing the sign. So I'm going to use the top one and the middle one first. All right, there's those two equations with some suspect writing. But, well, these will eliminate the y's right away, right? So when we combine these, those will eliminate. 6x's plus 12x's is 18x's. And negative 5z's plus negative 2z's is negative 7z's. Equals negative 2 plus negative 6 is negative 8. So there's that first equation in the new system for us. So I'm assuming we'll combine the top one and the bottom one next. And these two we can combine right away because the y's will eliminate again. So we got 6x plus negative 24x, negative 18x. And negative 5z plus negative 6z is negative 11z. And negative 2 plus 82 is 80. Well, I'm going to set these up like a regular system then. So I'll just put them up. I'll stack them. And I'm going to choose to eliminate the x, once again, because it will just eliminate directly for us. That will zero pair out. Negative 7z plus negative 11z is negative 18z. And then negative 8 plus 80, 72. So it looks like when we divide these by negative 18, that z is negative 4. And I'll go up to my order triple and just fill that in for the z value. Now that we have a z, we should choose the purple or the red equation to solve for x. So which one do you guys want? So again, we're just replacing the z with the negative 4 we found, and then we'll solve this. Alright, now that we have our x value, we'll plug it back into our order triple. Alright, let's use that top equation now to solve for y. So that sets up that first equation for us. Let's go ahead and multiply here. Now we'll combine like terms, and then we'll subtract 8 from both sides. And then finally, we'll divide both sides by 5. So it looks like y is -2, which I'll put in my order triple. Now again, you shouldn't stop there on an exam. You should check on all 3 equations, which you can just do with your calculator. And then you can know for sure on a test that it would be correct. There we go.